In this video, we'll go over the AP Physics exam test number 4 from our class. So we're looking at a key. On the acceleration time graph, the change in velocity is found. So we have an acceleration time graph. And you have some ground like this. And you're looking for the change in velocity. And the change in velocity is this area underneath the curve. This is delta V. So that would be, the correct answer would be number A. Problem number 2. A particular object starting from the origin may undergo any of 4 possible motions shown in the graphs below. In which case will the object be furthest from the origin at t equal 5 seconds? We need to know here that area is displacement for a velocity type displacement graph. So we're looking for the largest area under the curve. Well, this is plus area and that's negative area. This is negative area, plus area, and then negative area. That looks like about 0 displacement. This is negative area and that's plus area. But here, everything is plus. So this one will have the largest amount of area under the curve. Problem number 3. An object moves along the x-axis as shown below. At which point or points is the object accelerating? Alright, so we're looking on a position time graph. If you have acceleration, you need to have a curved thing. So we're looking for a curved path on graph. All right. If it has a straight line, then it means it has a constant velocity. So here A equals 0. There A equals 0, and not only does A equals 0, but it looks like V equals 0. And here, that's acceleration. So the answer is C only. On number 4. Suppose in making a round trip, you travel a uniform speed 30 miles per hour from A to B, and return from B to A at a uniform rate of 60 miles per hour. What would be your average speed for the round trip? Alright, so we're going from A and we're going to B. We're not told the distance. Well, it doesn't really matter. You can make the distance any value you want. So I'll tell you what I'll do. I'll make that distance, say, be here. The distance is X. It could be anything. I'll just make it 120 miles. So choose anything or work in the symbol X if you prefer. Now it does have to be a number other than 0. Now 120 miles, the time it takes to go the first part of the trip is 120 over 30 mph. So that would be 4 hours. The time to get back would be 120 at 60 mph. So that would be 2 hours. So total is 240 miles. And I did it in 6 hours. So that would be 40 miles per hour. Going the same distance is not the same thing as going the same amount of time. If you had done the same amount of time in each case, then the answer would have been 45 miles per hour. But because you're running at a slower speed over the same distance, you spend more time at the low speed, 30, than you'll spend at the high speed, 60. This is like most of the time in a class, say you make an 80, and only once did you ever make 100, then your average would not be 90. It'll be closer to 80. So in this case, the answer is closer to the 30 than it is to the 60. So it's not in the middle, like 45. It's closer to a smaller number, 40. So I could have told you off the bat that this and this number couldn't be right, that number couldn't be right, and it had to be this one. But that's because I have more experience than you probably do. The simplest way is to just choose a distance. It doesn't matter what this distance. Find the total time it takes to go up, the time it takes to go back. Find the total time by adding those two. Take the total distance going up and back and divide by the total time. Number 5. When applying the kinematic equations to an object, which of the following statements must be true? The kinematic equations are only valid if the acceleration is constant. Nothing else is a requirement. Number 6. Number 6 involves reading a graph. A graph of position versus time for a certain particle moving along the x-axis is shown. The horizontal axis are marked in 1 second increments. Okay, so we're talking that this is 1, 2, 3, 4, so forth. The vertical axis are in hundreds, so this is 100, 200, 300, 400, 500, so forth. What is the location of the particle at t equal 2 seconds? At t equal 2 seconds, the particle is located right there. I come right across and I see 500 meters. So let me put that down on my paper. X equal 500 meters. Next question. What is the particle's approximate velocity at t equal 3 seconds? Now to find that, I'm looking for the slope of the graph. Slope of xt graph. And that's basically the rise over run. So t equal 3 seconds, I go up here and I look. At 3 seconds, I'm on this curve here, which is basically a straight line. I could extend that straight line. It looks like it kind of goes down to about like that. So if I follow that straight line, I'm going to drop 500 meters, and I'm going to do it in 1, 2, 3, 4 seconds. So I'm going to lose 500 meters in 4 seconds. So V would be equal to minus 500 meters over 4 seconds. That's going to be minus 125 meters per second. Find the approximate average velocity over 4 seconds. Well, to find the approximate, you've got to find the change in position over the change in t. V average is delta x over delta t. Well, it starts out at 0 meters, and the time was 4 seconds minus 0 seconds. I need to find the location of the particle at t equal 4 seconds. And that appears to be right there, which going right across. Looks to me to be about 250 meters. All right, so we have that the average velocity is 250 meters minus 0 meters. That's 250 meters over 4 seconds. So the average is approximately 62.5 meters per second. Okay, I should have boxed this one up here previously. All right, let's see. That appears to be the last problem for this particular one. I will pick you up in the next video on problem number 7.